Introduction to gear and gear unit design, and this lecture is on laws of gearing, kinematics and geometry part 2. I have already discussed some gearing laws, kinematics and geometry in part 1, and in this lecture we shall continue with involute tooth gear, some basic properties and relations. Involumetry is a very important property of involute gear tooth. It is required to calculate different proportions of gear tooth, corrections, etc. So, this will be discussed. Backlash, what is backlash and how it is given, that will be also discussed, and tooth thickness at any radius, how it can be calculated, also an example will be discussed, and finally, minimum number of teeth to avoid undercut, that is under discussion. Now, let us consider the involute tooth profile. If we take a circle, this is the base circle. On the base circle, if we consider a chord like this, and if we take a point here on the circle and on the chord, and then gradually if we open this chord, unwind this chord on the drum, this point will move here, here. Location of these points will give us the involute teeth. In this case, in this figure, it is shown that an involute profile B to T has been generated, and then when it has this on the profile, it has reached C, we can consider, if we consider the length A C, A is the point of tangency of this chord when the C point is generated, or the point generating point has reached C. So, we consider that length A C, that must be equal to this arc length A B, arc length A B. So, we can write A C is equal to arc A B. Now, arc A B can be written as the base circle radius R B into this small angle plus alpha dash. So, sorry, this can be written as, we will make these corrections again here. So, A C is equal to R B, A C can be written again the R B into tan alpha, this R B into tan alpha dash. Therefore, we can write tan alpha dash is equal to phi plus phi dash. Again I repeat that phi is this angle. So, from this relation, we can write phi is equal to tan phi dash minus alpha tan alpha dash minus phi dash alpha dash, and this angle is now expressed as involute alpha dash, which is nothing but tan alpha dash minus alpha dash, where r dash means this radius is equal to r b by cos of this angle cos alpha dash divided by 2. So, module into theta number divided by 2 into cos alpha divided by cos alpha dash. That means, if on the involute profile, if we know the standard pressure angle, then and teeth number, from there at any radius we will be able to calculate this angle alpha dash, which is given by this relation. Alpha dash is equal to cos inverse r p by r dash into cos alpha. Next, if we consider this geometry, we have considered a full teeth. We have considered a full teeth, and we have shown here that this is equal to involute alpha dash. That means, or this angle, total this plus this is phi, or phi angle from this line to this line. Okay. So, that is nothing but involute alpha dash. Similarly, for standard pressure angle, this will be involute alpha. Okay. And here we consider this distance, that means from this point to this point is arc t by 2, that is half tooth thickness at pitch circle, and from this point to this point is t dash by 2, arc t dash by 2, that is circular, half of the circular pitch thickness at that radius. Now, if we consider the angle, then t by 2, arc t by 2 divided by the radius of this radius will give us this angle, half tooth thickness angle at pitch circle. Similarly, arc t dash by 2 divided by r dash will give the angle of this angle, this small angle at a radius r dash. Now, what we do? We add the angle, respective angle involute alpha dash with that. So, this means that this is giving the angle for the point of generation to the mid of the teeth at two different radius in terms of the half tooth thickness there and the involute of the corresponding angle. So, we can write at this angle will be same, we can write this relation arc T dash by twice R dash plus involute alpha dash must be equal to T dash by T arc T by twice R plus involute alpha. This means that simply we are considering this angle for in terms of the thickness at two different radius. Therefore, we can write at radius r dash the arc tooth thickness is equal to twice of the radius r dash whole into the tooth thickness at arc tooth thickness at pitch circle divided by twice into pitch circle radius plus involute of the standard pressure angle minus involute of the pressure angle at the new point through which the radius r dash is drawn. Okay. Or in other words, if arc tooth thickness at pitch circle is known, standard pressure angle is known, radius is known, then at any radius r dash we will be able to calculate the tooth thickness. Okay. So, this is the tooth thickness of standard gear tooth at any radius. Now, for internal gear, so this is the internal gear, here it is shown. In the internal gear, teeth is like this. These are the teeth. That means we can consider, say this is the teeth, or in other words, what is the gap there, that is the external tooth. Whatever the gap is there, that is the external tooth. So, at any radius, if we would like to find out the tooth thickness, what we need to do? We will consider that is given by T double dot T prime double dot arc thickness is nothing but twice pi r dash into z, that is the total pitch, circular pitch at that radius, minus the tooth thickness of external gear teeth. That means, in this case also we can calculate this one at any radius, and then from this relation we can find out what will be the tooth thickness at this radius. So, it is not difficult to find out tooth thickness at any radius r dash for internal gear also. The same method we can follow. So, here it is given the nomenclature. Now, what we have considered? We have considered a tooth of 80 number of teeth, 20 degree full depth, 2.5 module involute standard cut straight tooths per gear, external gear. Full depth means the addendum is 1 and the addendum is 1.25. So, we have to calculate the tooth thickness. at some point. In this case, we have to find out the tip thickness at the tip. Now, concept of module as a hint is given that to make the teeth equispaced and one should not foul to the other, we define the gears by its module and the base circle number of teeth. So, module, or it is sometimes called normal module, is pitch circle diameter divided by number of teeth. It is standardized and expressed in millimeter. So, this means that if we calculate the module by the teeth number or teeth number by the module, we will get the pitch circle diameter, standard pitch circle diameter, and tooth thickness is nothing but the standard circular pitch, which is pi into module divided by the 2, because at standard circular pitch which is pi m, the tooth thickness is equal to the gap thickness. Therefore, the tooth thickness can be written as pi m by 2, and in this case numerically we can calculate pi into 2.5 is the module. So, it will become 3.926990. Now, in these calculations, if it is done by calculator, we should consider at least 5th decimal place to find out the tooth thickness or any other value. Reason is that usually corrections, amount of corrections are not very high. So, if you would like to find out the change in teeth thickness, so it will be differences will be very small, maybe in the 4th or 5th places. That is why it is taken 5th places. Also, to get the value of involute of any angle, we will find the differences in 4th, 5th places. That is why we consider 5th places in numerical calculations. Now, tip circle radius, we have already developed the formula in terms of r dash. So, we will consider that r dash must be equal to z plus 2, 2 is here, in this 2 is the twice into addendum factor we have taken 1. So, z plus 2 into module divided by 2, which comes 80 plus 2 into 2.5 divided by 2, 102.5 millimeter. Next, tooth thickness has given this formula we have written, already we have derived this formula. In this formula, we the involute alpha dash can be calculated from the alpha angle. If we know the alpha and radius, we can calculate also alpha dash, and from there if we substitute the values, it comes like this. So, this is the involute alpha dash, which is for the alpha at the tip circle radius, and this is standard. One can remember this value, that involute 20 degree is equal to 0.0149 and 5th place, 6th place is 0, 0. So, we can remember this value 0.0149, and other values from say t dash we have already calculated, and r is equal to 100. So, r is equal to 200, and this thickness, this radius is this much we have already calculated. So, we find out t dash, which is equal to t dash arc thickness 1.9967 millimeter. It is quite interesting because this is 2 millimeter, close to 2 millimeter, and this means for 2.5 module straight tooth spar gear, with standard addendum the tip thickness will become 2 millimeter. So, again please note that in calculation of numerical figure of 5 decimal places is to be considered for accuracy. Now, I shall discuss about the minimum number of teeth in gear, interference, undercut, concept of gear tooth correction. When I shall come into the concept of gear tooth corrections, gear corrections in module 7, we shall discuss more about that corrections, but here I would like to mention that let us consider that this is the rack, basic rack. This one is the basic rack and this is the pitch line of the basic rack, and this is a pinion which is being cut, for which this is the base circle and this is the pitch circle. Okay. So, the contact can start at this point T when it is meshing with the basic rack, and if now we consider that the extra portion of the cutter that will go inside the base circle or below the base circle, or even this point moves here, that will go below the base circle, but that will not affect the gearing motion, as the contact will always remain on the involute portion. Now, if we consider this PQ portion, which is addendum factor into module, this must be equal to this pitch circle radius minus this Q to this distance, which is equal to nothing but this RB into cos of alpha. So, finally, we get RB is equal to R 1 minus cos square alpha, that is R into sin square alpha. Now, if we equate, then addendum factor into module must be equal to R sin square alpha, that is equal to ZC, a critical number of teeth for which contacts begin at T with addendum of rack is equal to 1 module. Okay. And we finally get the relations twice A f by sin square alpha is equal to minimum number of teeth. If we take the teeth number below this, then this T point will become below the base circle. So, here I have given A f the module. Now, if it becomes below the base circle, what will happen? So, this means it has come over here below the base circle, this point, mind it, this AF we have taken is equal to 1 into module. So, sorry, addendum we have taken 1 into module. So, addendum factor must be equal to 1. Okay. So, this means that this red line which we have considered, still it is having the addendum is equal to 1, but as it has come down, then this tooth profile will be something like this. And if we notice it, that not only here is a extra cut, but also this profile, this available profile, involute profile is above the base circle. not from the point of base circle. So, therefore, what will happen with teeth number less than this critical number, tooth form will be something like this. And this portion is called undercut. This is also called, as the cutter is interfering with the root, it is called tooth interference. In case of external tooth, tooth interference means the cutter is going below the base circle for active profile generation. So, this will be the undercut, and if there is the undercut that need to be modified, it is possible that we can modify the teeth and we can have the we can avoid this undercut. In case of modification, say for example, if I consider this teeth itself, we can not allowing the cutter to go to the full depth, or we can maintain a depth at least for which this involute will be generated from the base circle. Say let us consider this is the base circle. So, this means that we can withdraw the cutter a little bit and then we will get a profile something like this, and for which the trochoid will be something like this, and this is of course modified teeth, which is the profile shifted teeth, and it can be used for the gearing purpose. However, we shall learn more about the gear corrections in module 7. Now, concept of backlash. The teeth, what is if it is cut to the exact amount, that means if the tooth thickness is kept at pitch circle by the circular pitch divided by 2, and if they are allowed to mate at the exact center distance, in that case we will find that the teeth is touching here, that means teeth is touching at both the side, there is no gap. Now, there should not be any harm that the gear is operating at that conditions, but due to the thermal expansion which will be there due to the friction or even if increase in temperature, then what will happen, that tooth thickness will increase a little bit and then gear will jam. Also, if there is small amount of particles, debris inside the oil which is lubricating, then if that touches both the side, the wear will be more, or there is a possibility of malfunctioning is more than if there is some gap. To prevent that, what is there? Usually a gap is provided which is called backlash. Now, this backlash is usually generated by overcutting a teeth a little bit. Suppose we are not changing the center distance what has been calculated. So, in that case, if we just make the gear for standard gear such that this tooth thickness there at pitch circle, say which is pi into m by 2 is the arc tooth thickness is there and actual tooth thickness say T, we put actual, is slightly less than this value, very small amount, then this backlash will be provided and it is done for all gear. However, where we are changing the center distance, then these calculations come over amount of corrections, and normally we need not calculation such backlash and then calculation the depth of cut. Usually this automatic setting is there, or maybe if we cut twice or thrice on the same diameter, then automatically this gap will be generated. However, this is a different issue. So, ultimately this backlash can be calculated by this one, which is difference between the gap and the tooth thickness there. So, which can be calculated by the amount of correction is been provided for generating the backlash, which is very small. Here it is all the nomenclature is given from which we can have the concept of backlash, and we should remember, if the backlash is provided, then contact is always at the load point, not at the other side, other flank. So, we can follow the following books. So, in this lecture we have discussed about the basic geometric properties and laws of some gearings. We have also discussed about the backlash. We have discussed about what is undercut, what is the critical number of teeth. If the teeth number is less than that critical number, there will be undercut, there will be interference, and also we have discussed a little bit about the gear tooth correction, by which we can avoid such an undercut, but the correction and other part will be discussed in details later in module 7. Thank you.